Today's topic is generators in Python. Okay, let's begin with what is generator. Generator is a simple way of creating an iterator. Now, if you don't know what iterator is, then you can go and watch my last episode on iterators. In this video as well, we are going to cover the iterator real quick. So let's say you are defining a remote control class, which when you say remote control next, it gives you the next TV channel. So in order to do that, you can use this yield statement here. So what I'm doing is first returning CNN, then returning ESPN. So these are the list of channels that I have on my TV, and by calling this remote control next iterator, I am basically going through these channels one by one. Now this yield statement sounds similar to return, but it's not exactly return, because the difference between return and yield is that when you return, the function basically returns and it destroys all its local variables and so on, versus here you will see in a moment that it kind of preserves the state of last execution. So if I say itr equal to remote control, see, normally if I had return statement here, if this was return CNN, itr will get CNN assigned to it. But here, okay, so I made a mistake. So it should be remote control next. So if I say itr here, it is telling me itr is a generator object. So it is a generator which is basically it's creating an iterator for you. So when you have iterator, the common property of iterator is you should be able to do next on it. So when you say next, you get CNN. When you do next again, you get ESPN. This way, when you call next, it returns the first yield, then it remembers that it was here last time. So when you call next second time, it is going to return ESPN. This could be useful if you have a long list of values and you don't want to return them in one shot, because if you return them in one shot, it requires a lot of memory, and also you have to process those values here in this function. Versus with yield, you can produce your first result, which is CNN in this case, and you can just immediately return it. Then you can produce your next result, return it. So it has a benefit of saving memory as well as getting a quick processing. You can also do this. So for C in remote control next, print C. If you recall from iterator episode, you already learned there that for loop works on generators. So here remote control next is giving you a generator, and generator has an ability to be compliant with the for loop, so that for loop can iterate over each of these values. Okay, next thing we are going to cover is a Fibonacci sequence. We are going to produce that using a generator. Now before we go into details, let's see what a Fibonacci sequence is real quick. A Fibonacci sequence is basically a sequence of numbers where you basically keep on adding initial two numbers to get the third number. So in this case, the initial two numbers is 0, 1. So add 0 plus 1 is 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, and so on. So this is called a Fibonacci sequence. And what you want to do here is produce Fibonacci sequence using a generator. So we're going to write our generator function. Let's call it fib. And the first two numbers in Fibonacci sequence are always 0 and 1. So I just initialized A and B to be 0 and 1. So A here is 0, B is 1. And I'm just going to have an infinite loop here. And on each iteration, what you do is you yield first number, okay? And then your A and B becomes, so A becomes B. So in this syntax, A is now becoming B and B will become A plus B, right? That's what it is. And then what you're going to do here is, this is your main code. So here in this main code, you will say for f in fib. Now notice what will happen if I just keep on calling this for loop. Since there is an infinite loop here, it will never terminate. So I want to produce Fibonacci sequence until certain limit. So here I would say if f greater than 30, then break. So I want to just see Fibonacci, or let's say I want to see Fibonacci numbers between 0 and 50. Okay, so all right, so let's do this and then print f. All right, let's quickly run this. Excellent. So you see here I got the Fibonacci sequence 0 1 1 1 1 2, 2 and 1 is 3, 2 and 3 is 5, and so on. And it terminated when the Fibonacci number exceeded 50, because 31, 34 and 21 is 55, so that's why it exceeded. If you want to print like numbers until 100, then you get this. So the way this works is we can set a breakpoint and see how this is going. Okay, let's debug it using this thing here, and initially it will come to this guy, and let's see. So if I do F11 to go into that, okay, so I'm inside this function now. I will just keep on pressing this button to go to next line. As you see, A0 base 1 yield. So when I do yield, so from yield is short of like return, so it came back here, and when you look at the value of f, it is 0. Good. You go to next statement, and again you do next, or I would rather step into it. So when I step into it, it remembers that it executed this statement last time, so then it resumed execution from this point. So A was 0, B was 1. So the next thing that's gonna happen is A will be 1 and B will be 1. And again, I'm going to return A. So the value of A is now 1. So when you see F is 1 now. Okay, and if you look at your console, 1. So if you do next, you'll see 0 and 1 got printed here. So I will again go inside this, and A is now 1 and B is 2. It's returning A, which is 1. If you just do F10, it will not go inside this function. If you want to go inside the function, then you have to do F11 or use this button. Okay, so you kind of get how this works. All right. Okay, now the generators are better compared to class-based iterators, because you noticed here is, let me just terminate the execution here. So because you notice here is that we didn't need to implement ITR or next methods. If you recall from my last video, if you are writing a class-based iterator, then you have to write next and ITR method. Here you don't need to do that. Second thing is you don't need to raise stop iteration, because it will do it automatically for you. If I open idle once again, and let me show you the same example just to kind of highlight what I mean by you don't need to raise stop iteration. So here ITR is remote control, and next ITR. So you see it's stop iteration here. It automatically raises it for you. You didn't raise it here, right? So these are the benefits of generators. So that's about it, and thank you very much for watching this video.